This video is about absolute value equations and inequalities. Well, absolute value equations tend to look a lot more complicated than they really are. So what I want to do here is you've got all the mathematic explanation here on the page. I'm going to try to distill that into what I think is the simplest method. I think that one of the most powerful things on here, one of the simplest, is this part that I'm highlighting right now. The absolute value of a plus b equals c is equivalent to ax plus b equals negative c, or ax plus b equals. So basically, we're going to take an equation and we're going to break it into two things, okay? So you can read how to do that with example A. I'm not going to rehash that. I'm going to go ahead and solve these and try these, and you can watch as I go along. Let's take a look at A. We're going to take this and break it into two pieces. So the first piece is just as it's written. X minus 2 equals 3. The other part is going to be its opposite. So what I mean by that is it would be x minus 2 equals negative 3. We're going to solve both of these branches and get two different solutions. So for this first one, we're going to add 2 to both sides. So x equals 5. And for the other side, we're going to add 2 to both sides as well. So x equals negative 1. And these are the two solutions for A. That's really all there is to it. And this idea is key for the rest of this lesson. So what happens if we get an extra coefficient stuck in here, like this negative 4? Well, it gets to be kind of in our way. So what we want to do before we start is to get rid of that. Our ultimate goal, before we do like we did in A, to get that absolute value, the stuff in the bars, by itself on one side, and everything else on the other side. So I'm going to start off here by adding 4 to both sides of the equation. So our problem really becomes the absolute value, x plus 1, is equal to 2, as I add the 4 to both sides, negative 2. Now I can break it into my two problems. So problem number 1 is x plus 1 equals 2. And problem 2 is x plus 1 equals negative 2. We can solve that just like before. I'm going to subtract 1. So I get that x equals 1 and that x equals negative 3. And those are my two solutions. Let's go on to C. I'm going to do the same thing again here. I'm going to start by moving this positive 4 that's kind of in our way. So when I do that, my problem is the absolute value of x minus 3 is equal to 0. Because there's not a positive 0 and a negative 0, there's not two branches to this problem. It's only equal to 0. So really all we're going to do in this particular case is drop those absolute value bars. X minus 3 equals 0. Add 3 to both sides. X equals 0. Easy enough. Now let's take a look over at D. I'm going to start off just as I did before. I see that I've got this plus 3. It's got to go. So I'm going to subtract it from both sides. So my problem turns into the absolute value of x plus 2 then equals negative 2. There's a logical problem here. And that is that anything that goes into absolute value bars comes out as a positive number. Therefore, we've got stuff in absolute value bars equals a negative. It's not possible to happen. So if you end up in this situation, you don't have to keep working the problem. You can just put, there's no solution. Like I said, the reason that there's no solution is because that's impossible. I think that no solution is actually easier to write than impossible. I always like to try to throw in a real world problem where I can. So let's take a look at the try these B about the pH of water. So what we're talking about here is the pH of the water on the seal slide can vary up to 0.3 from its target pH of 7.5. We're going to use that information to write an equation and then to solve it and look at our solutions. So let's go ahead and think about what that actually means. So P, I'm going to make a variable called P, which I'm going to call, I guess, my extreme value. So we'll say P. And P, take away our target value, 7.5, should be 0.3. But I'm going to put this in here because it could go either way. It can be bigger or it can be less. So what we're going to do is we're going to take this and solve it just like we did before, splitting it into two problems. So I'm going to do this off to the side. P minus 7.5 equals 0.3. And P minus 7.5 equals negative 0.3. So we're just going to go ahead and add these. So if I add here, this would be P equals 7.8. And on the other side, it would be P equals 7.2. So we've got our extreme high value and our extreme low value. Do these solutions make sense? Well, let's see. 0.75 plus 7.5 plus 0.3, 7.8. That one checks out. 7.5 minus 0.3 is 7.2. That also checks out. So those solutions do make sense as the extreme high and extreme low. Let's take a look at what happens when we put inequalities into this mix. When it comes to absolute value inequalities, there's two schools of thought. The first is to solve them using a compound inequality, like is done here in example C, which is totally fine. The other idea is to break it into two different problems like we did before. I usually do that because it helps me stay organized personally, but you can do whichever you prefer. The other thing is that when we're writing our second equation, when we change the sign of the number after the equal sign, we're also going to change our inequality sign. We're going to flip it over. So let's look at, try these C and A, and you can see what I mean. Let me erase my little stray marks here. So A is pretty straightforward. X minus 2 is greater than 3. So its sister would be X minus 2 is less than negative 3. We're going to solve these just like equations. We're going to add 2 to both sides. So X is greater than 5. And the other one is going to be X is less than negative 1. I'm going to go ahead and plot this. So we'll say this is 6, 5, 4, 3, 2, 1, 0, negative 1, negative 2. We can notice that this is not got an equal to, so we can have open circles here. So I'm going to put an open circle in 5. And this says X is greater than 5, so we're going to shade to the right. And the other one is negative 1. And it says that X is less than negative 1, so we're going to shade to the left. Pretty straightforward. Let's take a look at B. We're going to do just like we did before and move that negative 3 out of the way before we really get started. So my problem is actually X plus 2, absolute value, is less than or equal to, we're going to add 3 to both sides. So negative 1 plus 3 is going to be 2. Now we can break it into our two problems. X plus 2 is less than or equal to 2. And X plus 2 is greater than or equal to negative 2. Same kind of situation. I'm going to subtract 2 from both sides. And I get that X is less than or equal to 0. And X is greater than or equal to negative 4. All right, so we can go ahead and put that on our number line. I'm going to start down here. So we'll say it's negative 5, negative 4, negative 3, negative 2, negative 1, 0, 1, 2, 3. I always like to be thorough when I'm labeling my number lines. These are equal to, so they're going to be filled in circles. So X is less than or equal to 0. Less than or equal to means we're shading left. And I'll complete that in a second. It's pretty far over, so I want to make sure I know how the big picture is going to look here. The other says that X is greater than or equal to negative 4. So here's negative 4. Greater than or equal to is to the right. So it looks like these two lines are going to collide, and our graph is going to look like this. Now let's take a look at C. I'm going to move that 1 over. Actually, I'm going to change colors so we don't get too confused here. So we're going to move that 1 over. 5x minus 2, absolute value, is greater than or equal to 3. We've taken that 1 away now. So 5x minus 2 greater than or equal to 3, and 5x minus 2 less than or equal to negative 3. Okay, so we're going to do just like a regular equation. I'm going to add 2 to both sides. 5x is greater than or equal to 5. So I'm going to be dividing here, but not by a negative. So our inequality sign is going to stay the same. This will remain. So it's x is greater than or equal to 1. On our other side, let's add the 2. 5x is less than or equal to negative 1. We'll divide and we'll get that x is less than or equal to negative 1/5. Don't let the fraction freak you out. That's okay. We're not going to be doing any crazy stuff with it. Calm down. I know. So let's take a look. We need to start by labeling our graph. So I'm going to say 2, 1, 0, negative 1, negative 2, negative 3, negative 4, negative 5, negative 6. So I'm going to find, and these are going to be filled in because of the equal sign there. X is greater than 1. So here's 1. Greater means to the right. Easy enough. The other one is x is less than negative 1/5. Negative 1/5 is going to be just slightly to the left of 0. So I'm going to say somewhere about here. And then less than means to the left. Excuse me. And there we go. When you're graphing on something like this, there's only so precise you can be, which is why I've got the answers below it to kind of corroborate why I chose that certain spot. All right, let's look at D. We're going to start by, of course, moving the 4 over. The absolute value of 2x plus 7. We're going to add the 4 to both sides, so this is less than 5. All right. 2x plus 7 is less than 5. And 2x plus 7 is greater than negative 5. So I'm going to start by taking the 7 away. So that's 5, 6, 7. So we're going to say less than 2. Easy enough. Divide, and we get that x is less than 1. We're going to add over here. So subtract, I'm sorry. Subtract the 7 from both sides, and we get that 2x is greater than negative 12. Which we divide by 2, and we get that x is greater than negative 6. Easy enough. So let's say negative 7, negative 6, negative 5, negative 4, negative 3, negative 2, negative 1, 0, 1. My goodness. That hardly even fits on that graph, doesn't it? Well, all right. So x is less than 1. So an open circle, and it's going to go toward our left for less than. And x is greater than negative 6. So here's our negative 6. It's open. Greater than means go to the right. So these two are going to meet, and our graph is going to look like this. I know that this lesson was a little more complicated than the previous ones. So if you have any questions, be sure to hop in on the synchronous time and ask them.